Now we're going to try to find a solution for the trig equations. So the goal here is to find the angles, and we need to isolate the trig functions. So you see number 10 right there. We have to find all the solution of the equation in that particular interval 0 to 2 pi. So we are looking for theta. So you see that first I need to isolate it, right? So I'm just going to do it like how we work with linear equation. -1 here, and then divide by 2. So I got cosine of theta equals to -1 over 2. So we have to refer back to the unit circle. What would be, what is the angle that gives you the cosine equals to -1/2? So I just want to make sure you remember it's x over r for cosine. And then we go to the unit circle. You see we have a negative number, a -1 over 2 x over r. So we are looking at 2 pi. We're looking at this values right here and this one right here. So we have two solutions. We have 2 pi over 3 and 4 pi over 3. Okay, so same thing for number 11. I'm gonna just go ahead and isolate the function. Okay, so you see that we have tangent. Tangent is y over x. So don't forget we have that 1 there. Okay, so once again we go back to the unit circle. So what we have is y over x, which is, and then you see right here we have a negative number. Okay, so for negative number, and we have radical 3 over -1, or we have this one, negative radical 3 over 1. So we have two angles. So we have 2 pi over 3 and 5 pi over 3. Okay, so we have to take care of the negative. Therefore, we have two angle. So to be exact, you can think of it at this way. Okay. All right, moving on to number 12. We do the exact same thing for these problems. So they are straightforward. However, for this one right here, we have to find all the solution. So let's first just isolate the trig function. Cosine of theta equals to square root of 3 over 2. So you see what we have for the angle, the square root of 3 over 2. What we have is right here. Yeah, because cosine is x. Yeah, so we have pi over 6. However, we're going to have to include all the coterminal angles. So I have to add 2k pi. And k simply is an integer. So k is an integer. That's why I give you that sign right there. So we need to include all the coterminal. So what about the other one? Don't forget that we have two solutions. You see right here, we also have radical 3 over 2. So that's why I also have 11 pi over 6. And don't forget, we have to include all the coterminal. Okay. Number 13, same thing. I'm gonna go ahead and take care of, well, I'm gonna go ahead and isolate. This is quite easy because we just move it over. Once again, I'm gonna go and look for, so don't forget that this one right here is y over x. Okay, and don't forget we have that negative right there. So what I have for radical 3, negative radical 3 over 1 is the this one, 2 pi over 3. Okay. Now we want to include, so you see we have this one right here, and we also have, so if you add pi to it, okay, so if you add, you're gonna end up with this one right here, 5 pi over 3, right? So if you keep adding pi, you will end up with the same answer. So that's why I'm just gonna add k pi, which is pi, 2 pi, 3 pi, 4 pi, and so on. So we cover all the angles. Okay. Now, if they give you just the interval from 0 to 2 pi, you only have to include all the solutions in there. You don't have to include the coterminal. Um, anyway, this one right here, what we have is the square. Sorry, so I have to do that. So what I have is 3 tangent square of 1 divide by 3, and then I take the square root. Now don't forget, when you take the square root, you end up with plus and minus. Okay, so we have possible 4 solution, right? Because we have to include both negative and positive 1 over radical 3. So what I have is pi over 6, 5 pi over 6 right here. So I have this one, I have this one, I have this one, and I have 11 pi over 6 as well, because we have both positive and negative. Okay. All right. So this one, hopefully you recognize this is a quadratic equation. So what I have to factor, right? So this is my way of factoring. I take 2 times negative 4, that's negative 8. I put the middle term, which is negative 7 here. I take two numbers. When you multiply, you get 8. When you add, when you multiply, you get negative 8. When you add, you get negative 7. So what I have is 1 and negative 8. Okay, now this is what I have for factoring. I then take the number and divide by 2. So how do I get that 2? That 2 is right here. Okay, just a coefficient. And don't forget, after that, I have to reduce it. So I ended up with negative 4 over 1 here. Now I'm ready to write my solution, my factors, sorry, my factors. So what I have, don't forget we're dealing with the cosine here. So you have to include cosine. So I have cosine of x minus 4 for this one. So this one first, minus 4, right? And then we have 2 cosine of x plus 1. That's this one right here, equals 0. So now what I have is cosine of x equals 4, and then cosine of x equals to negative 1/2. You can see that this one right here is out of the range, so we don't have a solution for it. Don't forget cosine and sine is bounded by 1, so we have no solution here. Okay, for this one, for the second one, I have cosine equals to negative 1/2, so that would be 2 pi over 3 and 4 pi over 3. Okay. This one, 1/2, negative 1/2. Okay, moving on. You see for this one right here, what I have is quadratic. Hopefully you recognize that. Okay, you recognize that. The problems we have, first, let's just move it to the other side. So what I have is cosine of x plus sine square plus 1 equals 0. Okay, we need to change. We have two different trig functions. One is cosine, one is sine. So what we need is to change it into one function. So I'm gonna change sine square. This is why I told you that you need to know the identity really well. So what I have is cosine of x plus 1 minus cosine square of x plus 1. Okay, equals 0. I'm going to change it up a little bit. So cosine of x plus 2 minus negative minus cosine square. Okay, I don't want to have the negative for cosine square, so I'm just going to multiply everything by -1. So I ended up with cosine square minus cosine of x minus 2 equals 0. Once again, we are back to quadratic, so I just simply factor cosine minus 2, and then I have cosine plus 1. Okay, once again, cosine of x equals 2 is out of the range, so we don't have to worry about that one. So this is no solution here. This one right here, we do have a solution, which is pi. Okay, right here, the -1 for x. Okay, so for 17, we do have quadratic, but this is easy because I can just simply move it to the other side and I can just take the square root. The only thing you have to be careful is when you take the square root, you ended up with plus and minus 1. Okay, so there's two numbers. Don't forget that cosine is 1 over sine. Okay, so what I have is uh, what's the answer for that? What's the angle that give you plus and minus 1? Pi over 2, right? But this particular question asks you for all the equation, I'm sorry, all the solutions. So we have to include the coterminal as well. So I'm going to add k pi for it. Why k pi? Because we have both negative and positive. So we go back and forth here and here. You see pi, and then we have 3 pi over 2. Okay, so if you keep adding pi to it, you're going to end up with the same answer. Okay, 18. So what I have for 18 is the quadratic. So simply factor. Okay, so I ended up with 2 sine of x plus 1. A lot of these problems just simply factoring. So we ended up with sine of x equal to 0, and then sine of x equals to -1/2. All right, for sine of x equal to 0, x should be pi. But don't forget we include all the solution, so it should be k pi. Okay, for this one right here, we have -1/2, right? For sine. So that would be this one right here. Okay, so I have 7 pi over 6, but I have to include all the coterminal. So I ended up with 2k pi. Okay, I also have to include this one as well, because this one also gives me -1/2. So I have 11 pi over 6 plus 2k pi. Okay. Now, number 19, what we have is two functions I told you earlier. So we're going to have to change. So instead of writing sine square, I'm going to write 2 times 1 minus cosine square 2 minus cosine of x. All right, simplify it. I get 2 minus 2 cosine square of x equals to 2 minus cosine of x. I'm going to move everything to one side. I'm going to add the left to the right because I want to keep cosine positive. So if I add it over, I ended up with 2 cosine square minus cosine of x. And then I have uh, 2 minus 2, so it's just 0. Okay, we're going to factor it out. So I have cosine 2 cosine of x minus 1. So we have cosine of x equal to 0 for 1, and then this one is cosine of x equals to 1/2. So what are they? For 0, that's pi over 2. X equal to 0, pi over 2, right here, right? But we have to include everything, so I'm going to add k pi to it. Okay, so for cosine of x equals to 1/2, that's pi over 3 right here, plus 2k pi. Okay, I also have one more for positive. The 5 pi over 3. Okay, so make sure you include that one as well, this one. And k is integer. Okay, moving on to number 20. Now you see that 20, we have 1/2 of x. You don't want that, right? So how about we let, first let me just move the 1 over. But I'm going to use substitution. So I'm going to let 1/2 of x equal to u. So now what I have is tangent u equals 1. Now I can solve it, right? So u is just pi over 4. But this is 1/2 of x. So solving for x, so I have to multiply it over. So x is going to be pi over 2. Okay. Now, don't forget we're going to have to include everything. We're going to have to include the coterminal. So 2k pi. Okay. 21, same thing. So earlier you have 1/2 x. For 21, we have 2x. So make sure you take care of that 2x. So don't just simply put it there. So sine of 2x equals to -1. Okay. Now, because I know sine, so sine of something equals to -1. So instead of using u substitution, I'm just going to put 2x. So 2x, we know 2x. What give us -1? What angle give us -1 for sine? So that's for y. This one right here, 3 pi over 2. You see that? So we have 3 pi over 2. Okay. Don't forget plus 2k pi. Now I want to isolate x. So all I have to do is divide by 2, which is multiply by 1/2 for everything. So I ended up with x equals to 3 pi over 4 plus k pi. Okay, so for this problem, we have to be careful because we want to find it in the interval 0 and 2 pi only. So I'm going to try one by one. So let's try k equal to 0. So x is 3 pi over 4. K equals 1. I get x equals 3 pi over 4 plus pi, which is 7 pi over 4. And then I have k equals 2, which is x equals 3 pi over 4 plus 2 pi, which is 11 pi over 4. But 11 pi over 4 is not in 0 to pi. So I'm just going to stop here. Okay, so we got two solutions. Okay. All right, moving on to number 22. You see that for 22, we have sine of x, and then, so we have sine of x, and we have sine 2x here. So what we have is the double angle. So we're going to have to change it into just the same function. So don't forget that sine 2 of x, I'm going to rewrite. Sine 2 of x, by definition, is 2 cosine x sine x. Okay, so now I'm going to rewrite. Notice that I actually don't care that I have cosine and sine because they are just factor. So if they're just factor, I can factor it out. So I have sine of x as the GCF. So I ended up with square root of 3 plus 2 cosine of x. And now we can solve it. So sine of x equal to 0, cosine of x equals negative square root of 3 over 2. All right, let's figure out the angles for 0. 0, that's just pi. So it's k pi here. Okay. Now, for cosine of x, that's the square root of negative square root of 3 over 2. That's going to be 5 pi over 6 plus 2k pi. And then don't forget we have another one. So 5 pi over 6, this is negative 3 over 2 here. But this one also negative 3 over 2. So I have to include that one as well. Okay. Okay, so for number 23, you see that we have a half angle here and an angle here. That's not good. So we should change it and recall sine square of x over 2 is going to be 1 minus cosine of x over 2. Okay, so what do we have here? We have to plug it in. So 1 minus 2, instead of writing sine square, I'm going to write the new one. 1 minus cosine of x over 2 equals 2 cosine square of x. You see 2 cancel out. I have 1 minus 1, so I ended up with just cosine of x equals 2 cosine square of x. So I'm going to move everything to one side because I have quadratic, and I can just simply factor after that. Okay? All right, so cosine of x equals 0. Cosine of x equals 1/2. So what do I have for 0? I have pi over 2 plus k pi. And then this one right here, I have pi over 3 plus 2k pi. Don't forget we have two solutions for it. 5 pi over 3 also give you positive 1/2. So I have to include it.